Okay, so we're gonna get started with our first problem in SOL 8.1a. Translate the following algebraic expression into a verbal expression. So this is the algebraic expression. -4 times x plus 3. Okay, so there's two things happening here. I have -4 multiplying to both x plus 3 and x plus 3 is adding to each other. So how do you handle these? Well, you can break them down into two groups. One group is multiplying and the other group is adding. So when you see ofs, they initiate a group. And then ands, they kind of act like connectors. Okay, so let's just see how this works. -4, or excuse me, the product of now I'm initiating my first group of -4, right? And that's my first participant in the multiplication. Who's my second participant? A whole group. The second participant is an actual group that's adding each other. So this -4 is not is not adding to 4. It's not adding to x and 3. It's multiplying to it. X and 3 are not multiplying each other. So how do we separate these things? Well, the first group, again, is multiplying. And the first participant is a 4. The second participant is a group of addition. So, and now I'm going to introduce my second participant as a group, not as an individual. The sum of a number and 3. Okay, so as you can see, this and right here is saying, hey, this -4 is multiplying to who? Who's the second participant? An actual group of addition, x plus 3. So that's how you handle that. Let's go on to our next question. So the question is how to translate these ones. Well, you see a square root. Well, because the square root, if you were to draw a square root, it can be long or it can be short. Because of that flexibility, it can include just one item or multiple. So either way, you're going to see that word of in there just because of that flexibility. So in this case is the square root of, okay, I'm initiating a group, but this is only going to be a group of 1. A number, and I do not put an and because otherwise I'm including the square root. I'm including more items in the square root, so there's no ands. Okay. Now I'm just gonna put an action here, minus 4. So the square root is only including the x, which you see in that case. And again, we just read from left to right, minus 4. No ands, okay? Well, here, I have a square root that's including both x minus 4, but x minus 4 is also doing something else together. They are having a difference. So, there's a difference between this, where they're just together under the square root, and what you see right here. So, they're subtracting each other and they're both being square rooted. So this is two groups. Okay. The first group is the square root. So that comes first. Okay. The square root of, okay, and what is my first participant? Well, actually, my only participant is a group that is having a difference. That's my only participant, as you see here, is the x minus 4. So I'm gonna initiate with the square root of the difference of. I'm gonna initiate my second group. And who are the participants of this group? A number and 4. So as you can see, there's only one participant in the square root, but this participant is a group themselves. Okay. So if it said square root of 4 and the difference of, then I have a different scenario, okay? But the only participant of the square root is a whole group, and this group is having a difference. That's how you translate that. Okay, so it says write an algebraic expression for each verbal expression. When you write an algebraic expression, just as English reads left to right, you write your algebraic expression from left to right. There's only a couple exceptions to this. We'll get to that in these examples. So it says the difference between, difference meaning minus, between who? A number and 5. There's a difference between them. Okay, a number and 5. So you will write it as x minus 5. The second one, 5 less than a number. So because of the word less than, that word is kind of comparing 5 to something, but it's taking away from this to this comparison. So if I said, hey, I have 5 less than dollars than you, whatever amount you have, I'm gonna take away $5 from. So in order to accomplish that, the number, even though it came second, it had to be written first, x minus 5. So that less than word acts as a switcheroo. Changes the order. Okay, so the next one is a number less 5. That's a left to right expression. A number less 5. Easy. And the last one, the difference between, again, left to right. So this is minus. Difference between 5 and a number. So you can see how the first three, there's multiple ways to write the same thing. And the only one that was different was the last, but same principle, left to right, and pay attention to that less than, that word then. Okay. So for number four, it says write an algebraic expression for each verbal expression. Okay. Well, again, pay attention to your of and ands. Okay, they kind of work hand in hand to each other. What is this group doing? Okay, this group is doing multiplication. Okay, where do I put the multiplication at? Where the and is at. Okay, now if you have two groups going on, if you have two ofs, you're gonna have to go to our other questions and see how I work those. But that's how that is. So this you will write the first participant in this group is a cube root of 5. So cube root of 5 and times, because this group is multiplying a number. So to write this appropriately, you would write 5 times the cube root of x. This is how you would write it from left to right, but this looks cleaner because anything that multiplies a radical is usually in front of it. Okay, so this will be your finished product. The second one, the quotient of, okay, so I see quotient, or I see the word of. What is this group doing? This group is doing division. Okay, and you put the division where you see the and. Okay, so number cubed is the first participant. X cubed and 5. Okay, again, if you have two ofs, just pay attention to how it's ordered. Okay, number 5. A high school is having a canned food drive. The freshman class collected 54 more cans than the sophomore class. The junior class collected 3 times the number of cans collected by the sophomore class. The senior class collected 10 cans less than the sophomore class. Well, what is the question asking? It says write an algebraic expression in one variable to model the total number of cans collected at the school. Okay, so if you take a look, they want an algebraic expression, so they don't want you to solve it. And the second thing they want is one variable. So that means that they want all of these situations linked to one unknown. Okay, and there's a lot of unknowns here. We don't know how many are in the freshman. We don't know how many are in the junior. We don't know how many are in the senior. Actually, they didn't give us anything. However, they are all linked to one unknown. They are all compared to one unknown, which is the sophomore class. You notice that the sophomore class, right, is repeatedly used as the point of reference, the comparison. So then we can use this to our advantage. The sophomore is what we're talking about, our X. Okay, so sophomore, we're going to say, hey, you're my unknown, my X. Algebraic expression is not an equation, so we're not writing an equation here. So let's write it. 54 from our freshman class, right? Plus X is our freshman. Okay, you see that? And then we're going to add our junior class, right? Our junior class is 3 times our sophomore. So this is our junior class, right? Plus our senior class is 10 less than. So that's actually saying whatever the sophomore class has, 10 minus that, 10 less than that. Okay. Now, did you notice I didn't use any equation signs? I'm not saying this is equal to, no. If I find out what X is, if they say, hey, X is 15, then I just replace all of my X with 15, add these numbers up. That's how much the total number would be collected at school. Okay? That's it.